Hi everyone, today we're going to learn how to calculate n by using the sum of formula. Hi everyone and welcome back, and in today's lesson we are going to learn how we will manipulate the sum of formula for a geometric series. So let's go and look at an example. Term 1 is equal to 54 and the constant ratio is equal to a third. Now this is a constant ratio, so we know that we have a geometric series. Now we want to calculate the value of n that will give a sum of 80. So basically we want to know how many terms were added together to give us a sum total of 80. So first off, we are going to write the sum of formula for a geometric series, and there it is. Now we are just going to do some substitution. In the place of the sum of, we will put the 80, and there it is. And then in the place of a, we will put term 1, which is 54. There we go. And then in the place of this r as well as this one, we will put the constant ratio, which is a third. And there it is. And now we will simply go about solving this equation so that our subject becomes n. Now, how will we do that? Well, we will simply say a third minus 1, which is minus 2/3. And because this is a denominator, we will multiply with it on this side to get rid of it. So we have 80 multiplied by minus 2/3. And that will give us a minus 160 over 3. And that is equal to 54 in brackets a third to the power of n minus 1. So now we will simply take this 54, which is the coefficient of this bracket, and we will divide with it on this side. So minus 160 divided by 3 divided by 54 gives us minus 80 over 81. And that is equal to a third in brackets to the power of n minus 1. Now this minus 1, which is a constant term, we are going to move it to the other side, and when we move an entire term, the sign will change. So the minus 1 becomes a plus 1, and we have minus 80 divided by 81 plus 1, and that gives us an answer of 1 over 81, which is now equal to a third in brackets to the power of n. Now the most hard part is done, so what we basically need to do now is we need to make these bases the same so that we can solve for this exponent. Now how can we make an 81 the same as a 3 or look like a 3? So we have 1 over 3 to the power of 4, which is equal to a third in brackets to the power of n. And then by using some of the exponent laws, we can write 1 over 3 to the power of 4 as a third in brackets to the power of 4, which is equal to 1 over 3 in brackets to the power of n. Well, the bases are exactly the same, so guess what? The exponents must be the same. So we can get rid of these 2/3, and then we have 4 equals n. So we added 4 terms to get to a sum total of 80. And that's it. See you next time. Bye.